Hello, my name is Craig Fry. I'm an environmental scientist at Sanitation District Number 1. Our organization is the Wastewater and Stormwater Authority for Northern Kentucky. Basically, what we're going to discuss today is stormwater management. And the reason SD1 is in stormwater management is if you develop a site that's more than an acre in our area, you have to manage the stormwater that runs off that area. You can't just put down a building impervious surface and allow that water to run off. So the developer, the designer, the property owner, they decide what kind of technique they want to put in to manage their stormwater. And there are many options to manage your stormwater, and the one we're going to talk about today is a vegetative roof. So if you think about the stormwater as it comes down from the sky, it lands on your it lands on a normal roof, it'll run off fast, right? Where if you put this vegetation down, it acts like a giant sponge and it will help absorb that water. So what we want to do is capture that water, retain that water, and then slowly release it back into the environment. By doing that, we help reduce the flooding downstream, we help reduce the potential erosion that's downstream, and also works as a water quality feature as well. So the roof that we have here at Sanitation District is an intensive roof, Savannah 3. It's 2 inches thick of growth media. There's 2 inches thick of drainage media underneath it. There's three major key components of the vegetative roof that you need to be very aware of. The one is a structural support. Not every single roof can handle a vegetative roof because they're really heavy, especially when you add that additional water on them. You have a saturated load that can, potentially collapse buildings. So you need to make sure you have a nice structural support. Two, your roof needs to be waterproof. So underneath the different layers of vegetation, the layers of soil, there's a very thick membrane that acts as our waterproofing layer. So as the water hits that roof, it'll filter through, infiltrate down into the soil, and actually goes into a drain that's below the soil, and then that will take it and put it down into the environment at slower rate. One of the key components of the vegetative roof is the media, the soil. You need to have the right soil type in here that will allow the water to infiltrate through, but you also need to retain and hold that water back. So then the plants also need to thrive in it. So you have to have the right mixture to get that good infiltration rate and allow it to hold it back. But you don't want to hold it back too much because then you could potentially cause ponding and flooding up here. You definitely don't want to do that. So it's a very critical piece of the functionality of the vegetative roofs. A really neat feature of our roof is we actually have the same square footage of a conventional roof that we can compare the two. So when the rain event comes in, we can go down into our stormwater lab where these both drain into, and we can collect data on how much is coming off the conventional roof and how much is coming off the vegetative roof. Like I was saying up on the roof, as the water makes its way through the vegetative roof, it's collected in under drain, and then it comes down through our stormwater lab here. And we have the same size of conventional roof up there, so we can compare the two. So if we get an inch of rain, we can look at the conventional roof and say, oh, we have 2,000 gallons coming off that, or whatever the number is. And then we can compare that number to actually what's coming off the vegetative roof. So we're looking at the volume reduction, and then we're looking at the retention time also. Because again, we want to capture that water and hold it and retain it for a while, and then allow the storm event to pass and then slowly release it. So we look at the volume, and we also are able to pull water samples from these tubes up here and take those down to our lab to get analyzed for things such as metals, nutrients, bacteria. And what we've seen is we really haven't seen a whole lot of fluctuation between the conventional and the vegetated, the green roof, as far as water quality goes. Because if you think about it, you don't have a lot of sources of input of potential pollution up there. So we have not seen a lot of water quality differences between the two, but it's that volume that is really what we really see. So this is the final spot where the water comes off the roof and discharges out into our park. And you can see these two scuppers here represent both of the discharge points. It's really neat during a rain event. You'll see the water coming off that conventional within minutes, like you would imagine. And then you may not see the vegetated roof come out at all. If it does discharge out, it takes about 2.5 hours to discharge out. If you look closely, you can see on the vegetated roof, the green roof, the buildup of mildew and algae. So that tells you that there's a slow release and this stays more wet, whereas you don't see any of that in the conventional. Because again, how flashy this water is, it comes out of that conventional and then stops. In the vegetated roof, it'll discharge, 3-4 hours later, but it'll discharge for like a good 2 or 3 days and just slowly drip out. And that's why you have that growth on there. So it's really neat, like during the rain event, to actually see, with your own eyes how well this thing's functioning.